So today we're going to go ahead and start with 3-2, which is all about balancing equations. Suppose you change one expression in a true equation. To keep the equation true, you have to balance the other expression.
The pan balance helps you see the relationship between two quantities. When the pan is balanced, the quantities on each side are equal. If the pan is not balanced, then the quantity on one side is not equal to the quantity on the other side. Let's explore the quantity x. When an x tile is placed on one side of the pan balance, notice that the pan balance becomes uneven, showing that the quantity x is more than nothing. Let's compare x with the quantity 1. The pan balance is still uneven. Drop a few more 1 tiles on the other side. As you add more 1 tiles, the pan balance becomes more and more even. Notice that when there are 8 tiles on the other side, the pan balance is completely even. This shows x equal to 8 is a true statement. Let's double the side containing the x tile to make it 2x. To balance the pans, you also need to double the quantity on the other side. Now, let's split the quantity on both pans in half. Dividing the quantity in the left pan in half gives you x and x. Dividing the quantity in the right pan in half gives you 8 tiles and 8 tiles. Removing half of the contents of both pans maintains the balance of the pans. Adding 7 1 tiles to the right pan again brings the pans out of balance, showing that the quantity of one side is not the same as the quantity of the other side. To bring the pans back into balance, add 7 1 tiles to the left pan as well. Because x equal to 8 was a true statement, you can replace the x tile from the left pan with 8 1 tiles, and the pan balance will still remain balanced.
So this idea for 3-2 and for chapter 3 is all about making sure that this pan is balanced. So I always think about a seesaw at the park, okay? To balance it, both sides must equal the same thing.
What must you do to this equation to make it true?
So it says 8 plus 7 plus 12. So I'm going to circle that. Would be on one side of my balance beam. And on the other side would be 15 plus a number. Well, what's 8 plus 7 plus 12? Well, I know that 8 plus 12 is 20, and 20 plus 7 is 27. So if I have 27 on one side, the other side I need to get to 27. Well, 15 plus what number is 27? Well, 15 plus 10 gives me 25, plus 12 will give me 27. So in order for my pan to be balanced, both sides must have 27. So if I have 27 here, 15 plus 12 is also 27. Again, I have 27 tiles here, and I have 15 here. So by combining the tiles on the left and comparing them to the numbers on the right, I know that I need to add 12 to the right-hand side in order for it to be even. So 27 equals 27. What about here?
The scale balances with 4x on one side.
So for this, they want to know if we have 4x on one side, so go ahead and write 4x, and then there's the equal sign, and then 20. There's 4x and 20, and that balanced the balance beam. Well, now I have 1, 2, 3, 4x plus how many ones? 1, 2, 3, 4, 5, 6, 7, 8, 9. And over here, I have 20. Well, is this scale balanced? No. So what did they do to change this to get this? Well, they added 9 over here. So what do I need to do over here? If they added 9 here, I need to add 9 to the right-hand side to balance out my beam. Since 9 was added to the left-hand side of the scale, you need to add 9 to the right-hand side of the scale so that it is balanced. On to part 2.
In this video, you will learn about the pan balance tool. You can use the pan balance tool to model and solve equations. You can add x and 1 tiles to each pan. Initially, the value of the x tile is set by the tool at random. If you add too many tiles to a pan, you can remove the extra tiles by dragging them off the pan. Each pan can hold up to 30 tiles. To specify an equation or a value for x, click on the Set Equation button. There are 3 options you can tiles option.
So we're going to skip over this because it's important, but I would much rather have us get to the meat of the information.
This scale is balanced. Notice what happens when you change one side. Now the scale is unbalanced. This scale was balanced with x on one side and 5 on the other side. Somebody changed the right side of the scale, and now the scale is unbalanced. What must you do to the left side to get the scale to be balanced?
So at one point, x was over here, and it balanced out when 5 was over here. So we have 1, 2, 3, 4, 5. So just when it was this. Okay, so they added how many rows? 1, 2, 3, 4 rows of 5. So if x equals 5, what must I add over to this side in order to balance it out? Well, I know that if x equals 5, I can add another x to equal this row of 5, and another x to balance out this row of 5, plus another x for this next row of 5, plus one final row of x for this last 5, and it should balance out. So in total, what did I add? Well, I added x's. The scale balanced when 1 x was on the left side and 5 1 tiles were on the right. Since 5 times as many 1s were placed on the right-hand side of the scale, you need 5 times as many x's on the left side of the scale to restore the balance. So you need 5 times as many x tiles on the left, so they added x's.
The scale balanced with 24 on the left and 6b on the right. What must you do to rebalance the scale?
So there was 24 over here and 6b over here. Well, right now we have 1, 2, 3, 4, 5, 6 times 4, which is 24. So over here, we now have how many b? Well, we have 2b. So they subtracted 4b. So what does b equal? Well, if there were 6 b's, we have 1, 2, 3, 4, 5, 6 rows. So each of these must represent b. 1, 2, 3, 4, 5, 6. Okay, so if they took away 4 rows, 1, 2, 3, 4, how much should I take away on the left-hand side? Here are some of your answer choices. Well, actually, here's the answer. Okay, so the scale balanced with 24b on the left and 6b on the right. So the number of tiles on the right side was divided by 3, or we took away those 4 rows. So if you divide by 3 or you take away those 4 rows, all that's left when you divide the number of tiles on the left side by 3 is these 8. So since the right side of the equation was balanced by 3, or divided by 3, you must divide the left-hand side by 3 as well. Okay, on to part 3.
Suppose you change both expressions in an equation. Start with the equation 3 times x equals 6. Multiply each side of this equation by 5. Finish by simplifying and end up with this equation. Can you tell whether this equation is equivalent to this equation? Equivalent equations are equations that have exactly the same solutions. The solution of n plus 20 equals 80 is n equals 60. Is n plus 20 equals 80 equivalent to n plus 20 minus 18 equals 80 minus 18? Explain.
So they want us to take n where it equals 60 and plug it into the n's here to see if it is true. So let's start with this one. If I have n, which is 60, plus 20, is n plus 20 80? Well, 60 plus 20 is 80, so that works. Let's see if it works for the second one. If I plug 60 in for n, I get 60 plus 20 minus 18. And they want to know, is that the same as 80 minus 18? Well, 60 plus 20 is 80. I get 80 minus 18. Over here, I also have 80 minus 18. Okay, I know 80 minus 18 is 62. Well, is 62 equal to 62? Yes, so these must be equivalent. Go ahead and copy those down. Try this next one.
The solution of 17 plus t equals 25 is t equals 8. Which equation is equivalent to 17 plus t equals 25?
So, go ahead and plug in 17 plus 8. Well, what's 17 plus 8? 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, so 17 plus 8 is 25. So if this is 25, what's 25 plus 8? Well, 25 plus 8 is not equal to 25. Over here, I have 17 plus 3, which is 20, and 20 plus 8 is 28, because t was 8. Okay, so if I have 28, is 28 equal to, well, what's 25 plus 3? Is 28 equal to 28? Yes, so this must be a solution. What about this one? If I have 17 plus 8 plus 8, well, 8 plus 8 is 16. 17 plus 16, they want to know if that will be equal to 25 plus 25. Well, what's 25 plus 25? 25 plus 25 is 50. Okay, is that equal to 17 plus 16? No, because this would be 33. So no, that does not work. So the only answer is 2. Go ahead and copy that down. When you're done, you can move on to what's next.